Welcome back, everybody, to Lesson 9 in the Foundations of Algebra course. Today, we're going to talk about division. Before we do, I need to talk to you about something serious. In order to afford the astronomical salaries of our directors and our ministers of humor at all the sites, we've had to sell ad space within our lessons. So I apologize for the interruption, but we'll be right back after this word from our sponsor. Okay, let's get right to it. We're talking about the operations, and we know that there are only two, addition and multiplication. We saw that subtraction was really just addition of the opposite. So let's figure out, how does division fit into this? Where did it go? Well, very similar to how we define subtraction, we're going to define division in terms of multiplication. So division turns out to be the same as multiplication by the reciprocal. Division is multiplication by the reciprocal. So what does that mean? Let's do some examples, and I think that'll be clearer. So let's say you want to do 3/4 divided by 5/7. So we're trying to divide by 5/7. Now that's the same, according to our definition, as multiplying by the reciprocal of 5/7, which is 7/5. And once you have that set up, we're good with multiplication straight across. So we get 21/20, game over. All right, here's another one. Let's say you want to do 6/7 divided by 5. You guys understand dividing by 5 is the same as multiplying by its reciprocal. So times 1/5. So 6/7 times 1/5. Straight across, we're good to go, 6/35. Looking okay? All right, let's back up a step, and we'll make sure everything's good with division with all different kinds of real numbers. Let's start with the integers. So if you want to do 12 divided by 4, hang on a second. You do not need to throw out all the stuff you learned before and just go with this new definition. You know, dividing by 4 is the same as multiplying by 1/4. That's fine. But here, we can just do this just with what we know, right? 12 divided by 4, it's 3, nothing to it, okay? You don't need to go crazy with this. But if you want to do 12 divided by -4, that's where the definition will help us, the connection between multiplication and division. So if you remember, we already know how the signed numbers work with multiplication. We had this chart a few lessons back, right? Well, since division is multiplication by the reciprocal, that sort of setup works just the same for division. So a positive divided by a positive is still positive. A positive divided by a negative is negative. And by the way, it's also, if they're reversed, a negative divided by a positive is also negative. When exactly one of the parts is negative, the result is negative. And then lastly, a negative divided by a negative is positive. All right? So we already know this. It's great. We're taking advantage of that connection between division and multiplication. So back to our problem. If we want to do 12 divided by -4, positive divided by a negative is negative, right? So, and in fact, looking at the numbers, -3. Last but not least, I should tell you, right? If it were -12 divided by 4, the answer is still -3, right? Because one of the parts is negative. Well, how about if both are negative? So if we had -12 divided by -4, negative divided by negative is positive, so we're going to get +3. All right, that's great. Let's turn to fractions. Now, we already sort of saw it with our first few examples. Here's something interesting. I want you to take a look at this. Let's say you want to do 2/9 over 1/2. Now, that might look a little weird to have a fraction over a fraction, but that's actually how we tend to write division at the higher levels. We don't use the division symbol all that much. So I just wanted you to see that notation. We'll practice it a little bit. But 2/9 over 1/2 is really the same. We know fractions correspond to division. So 2/9 divided by 1/2. And if you're dividing by a half, that's the same as multiplying by its reciprocal by 2. So that's 2/9 times 2. I'll put the over 1 there. And then we can multiply straight across. All right? 4/9. Nothing to it. Mixed numbers? Well, you know the deal. We don't operate on them. So if you want to do 2 1/3 divided by 1 1/5, immediately convert them into fractions, and then we're back to normal. So to divide by 6/5 is the same as multiplying by its reciprocal, 5/6, straight across, 35/18, and we got it. Decimals, if you wanted to do 9.36 divided by 0.3, all right, well, you guys remember, I'll do a little bit of drawing here just to get active. When you're dividing with decimals, you do have to pay attention to the decimal point. And typically what we like to do is shift the decimal over in the divisor, the thing we're dividing by. So move it over one place, and then we do the same thing with what we're dividing. So the decimal point is now here. I'm going to place it up top, and now we're doing 3 into these other numbers. So 3 into 9 goes 3 times. Well, that's nice. 3 into 3 goes 1 time. And 3 into 6 goes 2 times. So the answer is 31.2. Looking good. All right, I know you guys are good to go with that. This is really cool with the irrationals. And again, for us, we've been looking at roots. If you want to divide square root of 20 by square root of 2, this is so beautiful. You just, and remember, since this is tied to multiplication, you can divide anything by anything. So those aren't the same roots, of course. Square root of 20 divided by square root of 2, you just divide the numbers underneath the roots, the 2 roots. So it's going to end up being square root of 10. All right, we're good. Good to go with that. Now, I do need to stop for a second and emphasize there's one thing that is so dangerous in mathematics. You never, ever want to divide by 0. You can never divide by 0. Never divide by 0. So for example, if you have 4 divided by 0, there's that notation again, 4 divided by 0, no, that is not a number. Cannot do it, all right? If you have 17 divided by 0, no, can't do it. That is not a number, okay? What about 0 divided by 0? Well, do you see that 0 in the bottom? We're dividing by 0? I do too. Can't do it. No, cannot divide by 0. Never divide by 0. How about this one? How about 0 divided by 3? All right, well, wait. I love that you're being cautious, but you know what? This is okay. We know what this is. 0 thirds. Take the bar, chop it up into 3 equal pieces, keep none of them. You got 0. 0 divided by 3 is just 0. So it's okay. We just can't divide by 0. We can't have that 0 in the bottom in that setup. Okay? So just be careful with that. I'll give you one last thing before we go. I just want to give you a quick application because, in the real world, you're going to be using this all the time. So for example, let's say you have a patient and the patient needs a total of 4 2/3 milligrams of a certain medicine. And it has to be given in 3 equal-sized doses. So you got to split it up into 3 equal doses. How many milligrams of medicine should be in each dose? Well, we're already talking division, as we describe the problem, so you can see it. We're going to do 4 2/3 divided by 3. We want to split 4 2/3 milligrams into 3 equal doses. All right, well, take a look at that problem. First of all, we got a mixed number, so we don't want to deal with that. Convert it into a fraction. 14 thirds divided by 3. Dividing by 3 is the same as multiplying by its reciprocal. So we're going to multiply by 1/3, multiply straight across, 14/9, and we're good to go. Now I'll tell you what, if you wanted to put it back into a mixed number form, because it's kind of, I guess that's how it was given in the problem, you can. Just do the division, 14 divided by 9, and we get 1 5/9 milligrams. That's it. All right? Excellent job today, as always. I really can tell that you're working hard on this stuff. Keep it up, and I'll see you in the next lesson.